Geothermal piles or the energy piles. Here we have our earth. Geo means earth, while thermal means heat. Geothermal piles or the energy piles basically utilizes the energy within the earth. Now the temperature at the core of the earth is around 6,000 degrees Celsius, and it decreases when we move towards the crust, that is the earth surface. So let's take a earth surface. Let's take this ground. The temperature of the ground is affected by the part of the day as well as the season. That is, when it is sunny, or let's say when it is summer, the ground surface is warm. That is, the temperature will be high. And during night or winter, it will be cooler. That is, the temperature of the ground will be low. So that means that there is a fluctuation in this temperature. It is seen that this variation, that is this fluctuation in ground temperature, reduces when we go below the ground. Measurements show that the soil temperature below a certain depth remains relatively constant throughout the year. This is because of the thermal inertia of the soil. Therefore, we can say that at a particular depth, the soil temperature is always higher than that outside air in winter, and it is always lower than the air outside during summer. It is seen that is below a depth of 6 to 7 meter to 100 meter, this temperature fluctuation will be almost nil. That temperature will be around 12 degree to 17 degree Celsius depending on the locality. This difference in temperature, or this difference, is utilized to cool or heat the buildings using geothermal piles. Geothermal piles. It has a dual usage. Firstly, it is used to carry the structural load that is coming from the superstructure, and second, it can be used as a heat source or a heat sink. That is, during summer, these piles are used to cool the buildings, while during winter it is used to heat the building. Now, traditionally, the piles will be having a reinforcement cage, right? So this is our reinforcement cage. Now for geothermal piles, an additional member, that is a heat exchanger pipes, will be attached to the reinforcement cage. Now these pipes will be running throughout the length of the reinforcement cage, and it will be placed as a loop. Now this is a picture of the high density polyethylene pipes that is placed in the reinforcement cage. Here when you're constructing it, what you basically do is that once you have attached the pipes to the reinforcement cage, this cage will be lowered carefully into the borehole, into the hole. Now once it is placed inside the hole, the pipes will be filled with water. Now if this locality is a area where the temperature goes below freezing, then it will be filled with saline solution. Now once it is filled with the heat exchange fluid, it will be pressurized and it will be locked, alright, and then the concrete will be poured into the hole. Now once the concrete is poured and once it is set, that is once it has hardened, then we will reapply or repressurize the, we will reapply the pressure. So this is how the end will look. That is, the pipes are coming out and it is locked outside. Now these pipes will be connected to a heat pump. Now the actual working of the energy pile will be, you have the energy piles over here. These energy piles will be connected with the heat pump system of the building, and these heat pump systems will be connected to the secondary circulation system of the building. So during winter, what you do is that, uh, as I said, that this is a closed loop, right? So during winter, the water which is circulating inside this geothermal pile will collect the heat from the ground, all right, and then it will pass it through the heat pump. Now this heat pump will pass it to the secondary circulation, and this will eventually warm the building, all right. So in summer, what happens is that the heat from the building is collected by the water, and it is going down the ground, and this heat will be passed to the surrounding soil, all right. And when it is passing to the surrounding soil, the temperature of the water, or the temperature of the heat exchange fluid, is going down, and then it reaches the, which is basically cooler water, which is basically going back to the heat pump. Now this heat pump will pass it to the secondary circulation, which eventually brings down the temperature of the building, all right. Now again, this water will be collected, the heat will be collected from the building, and it will be passed to the soil, all right. Now, as I said before, the energy pile, it has a dual usage. That is, it will carry the load from the superstructure. That is, the pile will be under mechanical load. Now, additionally, there will be another load, which will be the thermal load, that is going to act on these energy piles. Now, the temperature effects on pile soil interaction. Because of this cycle of cooling and heating, the soil as well as the piles will expand and contract. Uh, will expand and contract. Now, this expansion and contraction of this pile as well as the surrounding soil will have a thermally induced axial stress towards this on this pile. Now, this will induce a thermally induced axial strain, which will eventually affect the soil pile interaction. All right. Now, all this together with some other factors will influence the shear stress that is acting on the pile surface interface. All right. And we also know that this pile is located inside soil, so it will be under the effect of a confining stress, right? Now, because of all this temperature changes, this radial stress will also be affected. All right. As I said before, that there is an axial stress which induces an axial strain, which also induces a radial strain to the pile. Now, that together with the effect of temperature uh, that has on the lateral earth pressure coefficient, as well as the thermally induced pore water pressure, will altogether induce a change in the radially acting confining stress. We'll go into the detail. Thermally induced axial pile stress is dependent on three factors. That is, how the pile is restrained, the pile restraint conditions. Second, it will depend on the thermal expansion coefficient of the concrete, as well as on the elastic modulus of the concrete. While the thermally mobilized interface shear stress change depends on, that is, there will be a change in shear stress that is acting on the pile soil interface. Now, that will be dependent on the thermally induced axial strain, as well as the temperature effect of the on the interface coefficient and the radial confining effective stress. Okay. Now, there can be a change in this radially radially confining effective stress, and this change in radially confining effective stress with temperature depends on the thermally induced radial strain plus the effect of temperature on lateral earth pressure coefficient and the thermally induced pore water pressure. That is, if it is a saturated soil and if you are heating up the pile, this water in the pores will get heated up, which is basically a pore water pressure. Now, this pore water pressure is called the thermally induced pore water pressure. Now, in severe cases, there can be additional building settlement due to this thermal cooling and heating, and there can be additional axial stresses that is acting on the pile, which can be tensile as well as compressive, and there can be a mobilization of a limited resistance to pile shaft. That is basically there can be a change in the uh, pile resistance. All right. So now, for proper design of efficient energy piles, a thorough understanding of thermo-mechanical properties of soil should be known, as well as the structural function of the piles under cyclic temperature conditions should be studied in detail. Now, the benefits of geothermal piles. So the geothermal piles basically uses a renewable source of energy, which is basically good. Then it is economically beneficial in the long run. Now, the initial cost of installing this geothermal piles will be a little high, but in the long run, it will be more economical. Using these piles will be space saving. That is, you are just installing the HD, these high density polyethylene pipes into this reinforcement cage, right? So when you're looking from outside, there is no additional equipments required. There will be an equipment required for the heat pump, but uh, compared to the solar installation, the equipments are very low. And also, using these geothermal piles have lower risk, because these pipes, this high density polyethylene pipes which is carrying the water or which is carrying the saline solution, it is embedded inside the concrete. So there is a low risk of damage to these pipes, as well as there is a low risk of contamination towards the groundwater table. Now, what are the disadvantages of using this pile, these type of piles? First and foremost, it is a newer technology, so contractors as well as customers are reluctant to use these new technology, because we are doubtful that whether using these geothermal piles will affect the load carrying capacity of this pile. Okay, as well as it will. As it is a new technology, there are very few skillful workers, so you have to train the contractors as well as uh, a layman to how do you actually install this pipes into the piles and into the ground, etc. And also proper guidelines should be provided. Now these geothermal piles are now being used in European countries, in Japan, in China, etc., and is now getting popularized. But guidelines, no proper guidelines have been given in every country. Like UK has some guidelines, China has some guidelines, but uh, proper um, proper guide should be given everywhere throughout and uniformly. Also, another disadvantage is that if you are, let's say that you are in a tropical, you are living in a tropical area and you're using geothermal piles. So basically, you will be using these geothermal piles to cool the buildings. So that is, you will be extracting heat from the building and you will be putting it into the soil. Now, this cannot be done in the long run, because that means that you are basically heating up the ground. So there should be a balance. Like if you are cooling the building, that is if you are extracting the heat from the building, and if you are putting it in the ground, there should be also extracting the heat from the ground and using it somewhere else. Let's say that you can use, if you are in a tropical location, you can extract the heat from the ground and you can heat up water. Design of energy piles. Now, as such, proper guidelines are limited. What we do is that the traditional design of the piles is a traditional design of the piles are done, and then you apply a higher factor of safety. Now, the problem with that is that the structure will be safe, but it will be uneconomical. So, therefore, we can say that more research is required to understand the thermo-hydro-mechanical behavior of the energy piles. Thank you. Stay blessed.